Okay, let's start with the first question. The first problem is this one. Number of solutions of the equation
Yeah.
9 by x minus 9 by root x plus 2, 2 by x minus 7 by root x plus 3. What is your first thought on seeing the question?
Um, I noticed there was a certain pattern, like when you see 2 and 7, it sums up to 9. So I felt you have to write both I felt you have to write something in terms of 9 by x minus 9 by root x and get something. So
You
that
are
was my first thought.
overcomplicating it too much. This is an equation.
Yeah, you have
What
to
is the first
rationalize it,
step?
like common denominator.
No. The first step should be, can we make it a quadratic? Is it
Yeah.
possible to make it a quadratic?
No.
No.
I mean, it'll be in terms of half powers and
If I do 1 by root x as t, it will not become a quadratic.
it will, yeah.
You don't know that equations that are not looking like quadratics can sometimes be converted into quadratics.
They can, yeah. I didn't think of substitution at that time.
It's not about at that time. This is the first thing that should come to you whenever you see it. It's not about that
Hmm.
time, this time. Now also
Yeah,
you're not saying it.
yeah,
You have to reduce the equation to the quadratic form. It is a simple substitution. This is so easy to solve.
yeah,
This is also directly factorizable.
yeah.
We will get the values of t. There will be 4 values of t, and then you will get all the values of x.
Oh, yeah. Then there'll be,
Answer is 4. Do you understand how it is so easy?
yeah, I got it. I was overthinking. Yeah.
You just have to think. Sometimes equations might not look like a quadratic, but if you do some basic thing, it becomes a quadratic.
Yeah,
This is a standard substitution. That as soon as you look at the question, you should think of that substitution. And if the question is over after that.
yeah,
Alpha, beta are roots of x square minus ax minus b. Imaginary alpha part of alpha is less than imaginary part of beta. Let Pn be equal to alpha power n minus beta power n if P3 is equal to minus 5 root 7i, P4 is equal to minus 3 root 7i, P5 is 11 root 7i, and P6 is equal to 45 root 7i. You have to find out mod of alpha power 4 plus beta power 4. Okay. Alpha and beta are roots of this equation, and the imaginary part of alpha is less than the imaginary part of beta. So the roots are going to be complex, and
yeah.
the imaginary part of alpha and beta have this inequality, and they have given you this stuff. So they have given you basically the values of alpha cube minus beta cube, alpha power 4 minus beta power 4, alpha
Yeah,
power 5 minus beta power 5. and alpha power 6 minus beta power 6.
Yeah.
Okay. So from this equation, we can say alpha square minus a alpha minus b is 0, and beta square minus a beta minus b is 0. Because alpha beta are roots, if we subtract, we will get alpha square minus beta square minus a common alpha minus beta is equal to 0.
Yeah.
This is what we are getting, and alpha and beta are not equal, so we can cancel the factors and say that alpha plus beta is equal to a.
Yeah.
That anyway we knew,
So
and
from
we
the
also
equation,
know
yeah.
alpha beta is equal to minus b.
Yeah.
Okay, we know these two things. We know alpha square minus beta square is this. So alpha minus beta to find out this stuff. So we need to make a connection between successive terms. So if we can make a connection between higher term and lower term, then that will be useful.
Yeah.
So, right. So what I will do is take this equation and multiply it with alpha power n minus 1. Take this and multiply it with beta power n minus 1.
Oh, and then, okay.
You'll get alpha power
Yeah.
n plus 1 minus a alpha power n minus b alpha power n minus 1 equals 0, and beta power
Yeah.
n plus 1 minus a beta power n minus b beta power n minus 1 is 0. And if we subtract, we get this minus a alpha power n minus beta power n minus b alpha power n minus 1 minus beta power n minus 1 is equal to 0, right?
Yeah.
So we are getting a way to figure out this is actually Pn plus 1.
Yeah.
This is what? This is Pn.
PN. Yeah.
This is Pn minus 1,
Yeah.
right?
Yes. Yeah.
So we are able to now relate all of these terms and in one single equation. 1 second, just hold on.
Yeah.
Right. So what I'm saying is we are able to write Pn plus 1 minus A times Pn minus B times Pn minus 1 is 0.
Yeah.
The reason we did this is because somehow you need to know a connection between these.
Yeah.
This is like the typical reduction formula that you see in integration.
Yeah.
where you connect in to in minus 1 and
I,
stuff.
yeah.
They have given you so many data points, so now I can use those data points to find a and b,
Yeah.
right?
Yeah.
So if I use that, I will be able to, for example, if I put n is equal to 3, I'm getting p4 minus a p3 minus b p2 is 0, right?
Yeah.
And P2 is alpha square minus beta square. We already got alpha square minus beta square is equal to A times alpha minus beta, right?
Yeah.
Correct. So, right. So we can use A times alpha minus beta for that, right?
Yeah.
Alpha minus beta into alpha plus beta. Alpha plus beta is A only. Yeah. So that is fine. Correct. So P4 is minus 3 root 7 I minus A times P3 is minus. So plus 5 root 7 I
Yeah.
minus b times p2 is a into alpha minus beta, right?
Yeah.
Is equal to 0. This is
Yeah.
one equation. Now put n is equal to 4.
Or we
You'll
can
get
do
a
654. Yeah. It's
huh?
nothing. I just said we could do 654 and then 543 instead of.
You put n is equal to 4, you will get a better equation which will not involve this.
Okay. Yeah.
N is equal to 4 will give us p5 minus a p4 plus minus b p3,
Yeah.
and n is equal to 5 will give us 6 and AP5 minus BP4. So these
Yeah.
two equations are enough to find A and B, right?
Yeah.
So let's find A and B first. That is our first target.
Yeah.
Okay. Uh, Fine. So let's find it. So P5 is 11 root 7 I minus A P4. So plus A into 3 root 7 I minus B P3 minus B. So plus B into 5 root 7 I, right?
Yeah.
Is equal to 0, correct? So
Yes. Yeah.
root 7i can be cancelled from everywhere, and we are getting 5b plus 3a plus 11 is 0.
Yeah.
And from this equation, I will get 45 root 7i minus a into p5. So minus a into p5 is minus 11 root 7 I into a, right?
Yeah.
Minus b into p4 is plus 3b root 7i. Again, root 7i will get cancelled, and you will get 45i. I also gets cancelled. 45 minus 11a plus 3b is 0, right?
Yeah.
So 11a minus 3b is equal to 45. And here I have got 3a plus 5b is equal to minus 11.
Yeah.
Multiply this by 3. This, okay. Maybe just multiply this by 11 and this by 3. So 33a minus 9b is equal to 135. This by 11, 33a plus 55b is equal to minus 121. Subtract, you would get minus 64b, right?
Yeah.
Is equal to 135 plus 121, 256.
Yeah.
So b is coming as 64, 4s are, and b is coming as 4, minus 4. So b is minus 4, right?
Yeah. And A is 3.
So minus 20, a is 3. So now we have a relation, this relation we have. Now we'll
Yeah.
use the
Now.
first equation,
Yeah.
right?
Now we can find it easily.
A is 3, B is minus 4. So in this equation, I can find alpha minus beta now.
Yeah.
So let's do that. Alpha AB into alpha minus beta, which is minus 12 into alpha minus beta. is equal to 5a 15 root 7I and minus 3 root 7I, right?
Yeah.
So this is 12 root 7I and 12 gets cancelled. So alpha minus beta is equal to minus root 7I, right?
Yeah.
So alpha plus beta is equal to, we got a, right? A is 3.
Yeah.
Now we know alpha and beta
Yeah.
because we know alpha plus beta and alpha minus beta.
Yeah.
So now you know alpha and beta, now you can find this,
Yeah.
right? So the point is, one way to do the problem was using the P3, P4, P5, P6. What we did was any quadratic equation, when they give us things like this, that alpha, beta are the roots, we can write alpha square minus a alpha minus b is 0 and beta square minus a beta minus b is 0. And if you want to make a relation over the terms n alpha power n minus beta power n, something like this, it
Yeah.
is only going to be possible if you multiply it with something, alpha power n minus 1 or something.
Yeah.
If you multiply this and this like this, you will start making terms like Pn plus 1 minus a times Pn minus b times Pn minus 1 is 0.
Yeah.
After subtracting, after multiplying and subtracting, you will get this recursive relation.
Yes. Yeah.
Given the values of P3, P4, P5, P6, it is simple to find A and B.
Yeah. That's
From
right.
here, if you find A and B, then you start with the lowest possible one. When you put n is equal to 3, you are getting a minus B P2. And P2
Yeah.
was alpha square minus beta square, which is A times alpha minus beta.
Yeah.
So you will find alpha minus beta. You already know alpha plus beta is equal to A, and you will get alpha and beta both.
Yeah.
That is one way to do it. The other way to do it would be, they are asking you this, you can try directly finding these terms by, they have given you these values, so maybe we can
Yeah.
directly try it, right? For
Directly. Okay.
example, you know alpha plus beta is a and alpha beta is minus b,
Yeah.
and this factorization is what, alpha minus beta into alpha square plus alpha beta plus beta square,
Yeah.
and this is alpha minus beta alpha plus beta alpha square plus beta square.
Yeah.
So if you directly try to do it, like this value was given, the value was given, right?
Yeah.
So we can write this part as, I need alpha power 4 plus beta power
Write it as
4.
alpha plus beta whole square minus AB.
This is
Alpha
this is
beta.
what we need, right?
Yeah.
So this is alpha plus beta whole square minus 2 alpha beta whole square minus 2 alpha square beta square, right?
Yeah.
So basically we can write it in terms of a and b, what we need, right? So here
Yeah.
we can write it as a square minus 2 into minus b, so plus 2b. A square plus 2b whole square
Yeah.
minus
2b
2b
square.
square. So if you simplify this, it will become a square plus 4b square minus 2b square, so 2b square plus 4ab.
4. Yeah.
4a square
4
b,
a square b, right? And a power 4.
a power 4. So we need this value,
Yeah.
but I think that the direct method is not going to be very easy.
Yeah. I tried that first and it didn't work.
So it will not work because there is too many for factorizations and all. You will have to do things about this also and this also.
Yeah.
Directly, if you try to find out, it will be too complicated. That's why the method that I did is much better. Because
Yeah.
in a straightforward way, using the data, we are getting A and B,
Yeah.
right? We are connecting all the higher terms to lower terms, right?
Yes.
So that method is going to be obvious to you only if you remember what you have done in definite integrals and in minus 2 and things like that.
Yeah.
Everything is connected. Like those types of things, if you have done before, then you know what to do. Or if you have done Newton's formulas for powers,
I think
Newton's
we did that a
sums.
long time ago. Yeah.
But the method is not very difficult to figure out.
Yeah, yeah,
It's
it's
a
not.
standard method which is known to people. So if you have seen it once also, you should realize that I can connect high powers to low powers.
Yeah.
Okay, what is the next one?
Yeah, I'll just send it.
Okay. If alpha plus I beta and gamma plus I delta are roots of x squared minus 3 minus 2i x minus 2i minus 2, then you have to find out alpha gamma plus beta delta.
Yeah.
Okay, so fine. So
I
basically
got
we
two
have to find
relations.
the roots of this, no?
Yeah. Instead of that, I had tried a different method where we used the sum of roots and product of roots relations, but none of them worked to get this thing, the question that they
You're,
have
choo-
asked.
you're choosing the worst method to do it. See, you have to go for simple things. Why are you complicating your life so much?
I thought sum of roots would be the easier way because you can get to know it
There are
from the
four
quad.
variables. How it will be easy? How will it be easy?
Yeah.
There are four variables. Sum of roots and product of roots will be weird combinations of those. Do you understand what I'm saying?
Yeah. Yeah.
If you need a particular combination of these four unknowns, it is going to be annoying to try to get it from sum of roots and product of roots.
Yeah. I tried the usual quadratic way also.
Just get the roots by quadratic formula.
I tried that, but maybe I went wrong somewhere.
There's nothing to go wrong. It's an equation with given coefficients. There's nothing unknown.
Yeah.
You just follow the quadratic formula and see what comes. 4 into 1 into this, so plus 2i minus 2, right?
Yeah.
By 2. So inside you have 3 minus 2i plus minus. This will become 9 plus 4i square, so minus 4 minus 12i plus 8i minus 8, right?
Yeah.
This is 5 minus 8 to minus 3, and this is minus 4i.
-4 and yeah.
This is what we
I,
are getting. We are getting
yeah.
x is equal to 3 minus 2i plus minus root over minus 3 minus 4i.
Yeah.
Now, if you don't know how to do square roots of complex numbers, then you can't do anything. If at this stage you don't know what to do, then it will be difficult for you. Do you know what
Yeah.
to do here?
I
It's
wasn't sure actually.
it's a very normal thing how to find the square root of a complex number. It's a
I
basic
think
concept.
you have to write, I think, for example, y square is equal to -3 -4i or
We will just do normal standard things. We'll call it a plus ib and we'll
oh yeah.
square it. You don't have to memorize anything. These are basic steps. I'm squaring it. What will come here?
Yeah, then you can compare the coefficients.
It will be obviously this. And what we are getting is a square minus b square is equal to minus 3 and 2ab is equal to minus 4, right?
Yeah.
Can we find a and b from here?
Yeah, you can.
How? What should I do?
You can write AB is equal to minus 2. You can write, or you can just take B on one side. Like you can write B square is equal to A square plus 3. And we also know that AB is equal to minus 2. So you substitute one of them in terms of the other.
Right, it's a standard thing. You will put b is equal to minus 2 by a in the first relation,
Yeah.
right? You'll get a square minus 4 by a square is equal to minus 3, right?
Yeah.
So then a square minus 4 by a square is minus 3. So you're getting a fourth degree equation now. And that equation is going to be a power 4 minus 4 is equal to minus 3a square. A power
Yeah.
4 plus 3a square minus 4 is 0. We can easily factorize it. We'll say plus 4a square minus a square minus 4, right?
Yeah.
We'll get a square common, a square plus 4 minus 1 common, a square plus 4. So therefore you're getting a square minus 1, a square plus 4. And you should realize that whenever you say this is equal to this, the a and b are supposed to be real.
Yeah.
So this cannot happen. This cannot be 0. So
Yeah.
a can only be plus or minus 1 now, right?
Yes.
And if a is plus 1, b is minus 2. So one complex number is 1 minus 2i. The other complex number is when a is minus 1, b is plus 2,
Yeah.
right? These are the two possibilities for me.
Yeah.
These are the square roots of my complex number. I will put them here and I will get 3 minus 2i plus or minus 1 minus 2i divided by 2, or 3 minus 2i plus or minus minus 1 plus 2i divided by 2.
Yeah. You get the same. Yeah. It'll be the same thing.
When you do plus, you will get 4 minus 4i by 2. So 2 minus 2i, one option. When you do minus, you get 2 and 2i gets cancelled. So you get 1, right?
Yeah.
And from here, when you take the other version, minus 1 plus 2i, when you add, you get 2 and minus 2i, and this thing gets cancelled. So 2 by 2, 1. When you do subtraction, you get plus 1 minus 2i. 4 minus 2, 4i by 2. So again, you get 2 minus 2i, right?
Yeah. You'll get the same thing. Yeah.
So basically, you are getting two roots, 2 minus 2i or 1, right?
Yeah. That's right.
Great. So now I know what are the values of these, right?
Yeah.
So we can call any one of them, like let's say alpha is 2, beta is minus 2 in one case, and gamma is 1 and delta is 0, right?
Yes. Yeah.
So alpha into gamma is 2 and beta into delta is 0. So answer is 2. You can check the other choice also, it will should be coming same.
Yeah. I'll just try that.
If you choose 1 as this one, you will get alpha is 1,
Yeah. It works. Yeah.
and now you'll get the lambda and this different. But the point is that
You have to
there was
square root.
nothing complicated here. If you try to do it by sum of roots, product of roots, you will get many combinations of these variables. It will be difficult to figure out.
Yeah.
If the quadratic equation is given with known complex numbers, direct quadratic formula is the best way to get the roots.
Yeah. But I totally missed. I totally forgot about the square root thing.
But if you don't know, this is like a basic concept of complex
Yeah, it
numbers.
is. I thought of doing it the quadratic way, but once I reached the square root part, I totally forgot about that thing.
If you see your Allen book, square root of complex numbers would be in the beginning pages. This is the first
Yeah,
thing
that's
that you
right.
are taught.
Yeah, I missed that.
Once you, if you don't know how to do square roots and all on basic operations, then obviously you'll not be able to do it. But
Yeah,
but the question is testing whether you know these basics. If you know this
yeah,
basic, the question is super easy actually. There's nothing complicated in this.
yeah,
If anybody knows how to do this, it's over in 2-3 minutes. There's no issue, right?
yeah,
Okay. Let integers a and b belong to integers and a and b belong to -3 to 3 such that a plus b is not equal to 0. Number of all possible ordered pairs. Number of all possible ordered pairs AB for which z minus a mod of z minus a by z plus b is equal to 1, and the determinant z plus 1 omega omega square omega z plus omega square 1 omega square 1 z plus omega. This determinant is 1, where z belongs to complex numbers,
yeah.
is equal to how many such roots are there? And they have said omega omega square are roots of the normal thing that we expect. They are cube roots of 1, right?
Yeah.
Okay,
So,
so we have to
yeah,
make a and b, we have to find integer values such that this and this are both true.
yeah.
Okay, so fine. And
I
this
was able to solve the
identity,
determinant, and from there I got z cube is equal to 1.
such that under the bridge, uh,
The issue I faced in this was I got one more ordered pair than the actual answer.
for which this is true and this is true. So for the four possible vectors that belongs to complex numbers. So the determinant, if you try to solve the determinant, you will get a condition on z,
Yeah,
and from here also you will get a condition on z. Um, okay, 1 second. What we can say from here is first of all, mod of z minus a is equal to mod of z plus b.
yeah,
So what that means on the number line, z should be on the perpendicular bisector of which points?
of a and minus b.
Basically, z lies on the perpendicular bisector of a and minus b, and a and minus b are real numbers, right? So
Yeah.
they are definitely on the number line, 2 points on the number line, right?
Oh wait, so I didn't see the part where they wrote z belongs to complex. I mean, I got the condition that z cube is 1, so it's cube roots of unity anyways. I considered 1 as 1.
Z lies on this line, we know,
Yeah,
and it can be anywhere on this line. Now, we know that this line is like the line parallel to the y-axis, right?
yeah,
So we have to think of this and we have to try to satisfy this also, right?
yeah,
So, okay, so let's think of what happens when you do this discriminant.
yeah.
So,
So I just
what did you
added two
do?
of them. Yeah, I'll just get my working out.
You can add on row 1, I think you can add row 2 and row 3.
Yeah, I did two row. Yeah, I did that
Let's
as well.
say if we do row 1 becomes row 1 plus row 2 plus row 3, right?
Hmm. Yeah, that's right.
Then what you will get is z plus 1 plus w square, which will become 0 for z only, right?
Yeah,
And here, what will happen? Z plus w square plus w plus 1. So z again gets.
yeah. So you'll get three z's in one row, and you can take z common out.
So you are getting something like this, and w square 1 and z plus w is equal to
Yeah,
1. So we can take z common, and we are getting 1, 1, 1 now. W
yeah.
w square, z plus w square, 1, 1, z plus w.
After this, I just subtracted the first column from the second column and the second column from the third column to get two zeros.
Right. So you can say first column is this minus this you can do,
Yeah,
or whatever, just get two zeros.
yeah.
So,
I left the first column because it was simple, so I didn't want to subtract anything from that.
so you can subtract second column is first, second minus first, right?
Yeah, that's right.
So second column will become 0, this minus this, so z plus w square minus w and 1 minus w square. And
Yeah,
third column also you can say is third column minus first column.
yeah,
So it is 0, 1 minus w, and here it will be z plus w minus w square, right?
yeah,
And then evaluating it is just calculating this thing, right?
yeah,
So we can see here this is z plus w square minus w multiplied by z plus w minus w square minus 1 minus w into 1 minus w square, right?
yeah,
So let's calculate that. You will get you will get z square plus zw minus zw square plus w square z plus 1 minus w power 4 is w minus
yeah,
wz minus w square plus w cube, which is plus 1, minus inside the bracket you have 1 minus w, 1 minus w square minus w plus w cube, so that is 1. So
yeah,
we are getting this cancels this, z w square, this cancels this,
yeah.
and we have 2
The ones will
here,
cancel out.
which will get cancelled with these,
Hmm.
and we'll have z square
Is one
minus
by z.
w minus w square plus
Oh,
w square plus w.
yeah, it cancels out.
So finally, after simplifying, we're getting z cube.
Yeah, is one.
Okay, great. So z cube is 1. So z options for z are 1 omega omega square.
I totally miss seeing that one cannot be included in that.
Why can't it be included?
They said it belongs to complex numbers. I mean,
So
Z belongs.
1 is not a complex number.
I mean, in that, yeah, in a sense, all real numbers. Okay, yeah.
You don't know that 1 belongs to complex numbers.
Yeah, it does. Like, all real numbers are complex, and
Did they say z1, z is perfect, purely imaginary?
they didn't say that. They just said it belongs to complex, yeah.
So what does that
I,
mean?
nothing, sir. I even included one when I solved the question.
Why are you confused between the meaning of sets?
I got the,
Can
I
you stop
calculated
thinking
in,
of the answer and tell me what the real meaning of the word C is and R? What is the meaning of
yeah,
C?
so it belongs to complex numbers. Like,
Complex numbers, does it include 1 or not include 1?
I mean, it does. Because
So
it can be
what's
represented in the terms of A plus IB.
so what's the problem?
Yeah, there's no problem.
Z has three possibilities, and then you have to look at Z should also be on the midpoint of these two numbers.
Yeah, that's right.
And it should be on the perpendicular bisector somehow. So if you
Yeah,
think of uh, W, for example, if Z is W, then W we know is minus half plus I root 3 by 2, right?
yeah,
So if that was the case, then the real part, it is possible that Z could be W, then the real parts of these have to add up to minus 1, right?
yeah,
So basically what you have to say then is that minus half is on the midpoint of A and minus B, right?
yeah,
Do you understand what I'm saying?
yeah.
So what we can say is, in that case, what are the possibilities for A and B? They are integers from minus 3 to 3, correct?
Um, Sir, can we consider one to make it simpler?
You have to consider all options.
I mean, yeah,
You think we'll ignore these options? It's not like they
no,
have a choice in it. What do you mean, can we consider one? Obviously, we have to consider it, but can we ignore omega and omega square?
no,
You think you have a choice in the matter? You will ignore some roots.
no.
So, what do you mean, can we consider? Obviously, we'll consider. We'll consider everything.
Yeah,
Number of all possible ordered pairs are being asked, not just the ones which are easier.
yeah,
Do you understand what I'm saying?
yeah.
So, can we ignore z is equal to w?
We can't. But
What but?
nothing. I just meant it's a mod function, so I just considered one, and I don't know why I got one extra ordered pair. You're supposed to include all of them, yeah.
Find the roots. Find the possibilities for a and b.
Yeah,
If z is 1, you will get simpler
oh,
answers. If
yeah,
omega
I
and
got like,
omega square, you will get more roots.
yeah, that's right.
The sum of the real parts of these two should add up to minus 1
Yeah,
in the case when it is omega or omega square both.
yeah,
So minus 1, it can add up in minus 3 and 2, minus 2 and 1, minus 1 and 0. These are the possibilities.
yeah,
There is no other way to get minus 1 now. Do you
yeah,
understand what I'm saying?
yes, yeah,
So we can reverse the order and get 2 for each. Like here we can say B is A and B, opposite also we can do,
yeah, that
right?
works.
And if you want to get the situation for 1, then the sum of these two have to be, real parts have to be 2.
Yeah, uh,
Some of the real parts can be 2 in again different ways. You can get minus 3 and that is not possible. Minus 2 and 3 is not possible. Minus 1 and 3 is possible, right?
yeah,
0 and 2 is possible. 1 and 1 is possible, correct?
yeah,
After that, nothing is possible. And again, you can flip the order of A and B and you will get different pairs.
Yeah.
Do you
0 to.
understand what I'm saying?
Yes, sir. Yeah.
Ultimately, you have to ensure that A plus B is not equal to 0. A and B both are between -3 and 3 and they are integers.
Yeah.
And we are using the fact that this locus means that Z is on the perpendicular bisector between these two integers.
Yeah.
We already know Z cube is 1, so Z has only 3 options. We don't have to consider these two are not different because both of them lead to the same real part.
Yeah.
Do you understand what I'm saying?
Yes.
So after that, you can figure out the answer. Next question.
Yeah, I'll just send. For
Okay.
some reason, I'm getting the incorrect answer for this. Like, it's not there in the options. Should I tell what I tried for this, like the first time?
1 second.
Yeah.
Summation of this series is this. We need to know the 1 TR term, 1 by TR and all. In order to find the limit, we need to know 1 by TR.
Yeah.
So the whole summation has been given. The answer of the summation is given.
Yeah.
Okay. So, so first of all, looking at this, we can try to find out what is T1, T2 and all. We can easily get that
Yeah. So,
because we can put n is equal to 1, then that will be T1, right?
yeah. So just one doubt about this question. Like, they're asking us to find the summation of 1 by TR, right? So
Mhm.
basically, it's just a reciprocal of this, but just a summation of that, right?
Yes, but that is not very easy.
Actually, I did get something. So when you take the reciprocal and when you group the terms, like if you multiply 2n minus 1 and 2n plus 5, you will
What do you
get.
mean? What do you mean when you take the reciprocal? Do you know what is 1 by T1, 1 by T2? How are you grouping the terms? This is not the sum of, these not the terms. This is the sum.
Okay.
What do you mean you're grouping the term?
I
We
thought
don't know
I
any
thought
term.
TR, I thought TR was one term where R is any number and then we find the summation of TR
Do you
till
think
n.
this is telling us TR?
I thought this was just one term.
You don't know the meaning of the summation symbol.
Yeah, it means like the sum of many terms, and I thought TR is one term and we have to find the summation for r is equal to 1 to n.
Do you understand what you're saying and how wrong it is?
Yeah, I think I misunderstood the question.
What have you understood? Right now, also, you don't seem like you've understood. What is the understanding right now you've got?
Oh, wait. I understood it now. I misunderstood the question initially. Like, initially, I thought TR is a single term, but TR is a summation of a term which is 2n minus 1 and so on.
All we know right now is that T1 plus T2 plus Tn is equal to this.
Yeah.
We don't know the nature of each individual term.
Okay. Yeah.
You can't just say that this expression is one term of it.
Yeah, I misunderstood it. Yeah.
Obviously, we can't do anything right now because we don't know what T1, T2, T3 looks like.
Yeah.
What we have to do here is summation of something like this.
Yeah.
If you don't pay attention to the problem, then you will do weird things. That is not the way to do it. Obviously, this is the sum. It's not the general term. If it was
Yeah.
general term, it is very easy.
Yeah. Then it's fine.
Then we'll just take reciprocal and start doing limits and all here.
Yeah.
We have to find what terms are there which add up to a summation like this, and then that term we have to take here.
Okay.
So that's why we are going to try to put n is equal to 1 here. So basically the summation will be simply t1, right?
Yeah.
If you put n is equal to 1, you'll get just t1. You'll get 1, 3, 5, 7 by 64, right?
Yeah.
If we put n is equal to 2, we will get t1 plus t2 is equal to n is equal to 2, you'll get 3, 5, 7, and 9. Okay, so there is at least some pattern here. T1 plus
Yeah.
T2 is this. T1 plus T2 plus T3 is going to be, when you put n is equal to 3, it starts from 5. 5, 7, 9, 11.
Yeah.
Right?
Yes. Yeah.
So right now we know that T1 plus T2 plus Tn is this, right?
Yeah.
Okay, so we'll write this 2n plus 3, 2n plus 5 by 64. And then we'll write the one term before it, T1 plus T2 plus Tn minus 1, right?
Yeah.
That would have been something that not the one step before this, right? It would start
Yeah.
from 2n minus 3, 2n minus 1,
One
2n
and
plus 1, and 2n plus 3.
yeah.
Do you understand?
Yes. Yeah.
This will be obvious only when you write one or two terms, then only you'll realize what is the pattern.
Yeah.
Why am I doing this? Because I can now subtract and get Tn from these two.
Nice. Yeah.
All of these will get removed. Only Tn will be left. So Tn, when you subtract, we can take many things common. We can take this term, this term, this term common when we subtract,
Yeah.
right? We'll get 2n minus 1, 2n plus 1, 2n plus 3 divided by 64 common, and we'll have 2n plus 5 minus 2n minus 3, right?
Yeah.
So this is clearly 8. 8 by 64, you get a 8 here.
Oh, nice. Yeah.
We are getting now our Tn term we are getting is 2n minus 1, 2n plus 1, 2n plus 3 divided by 8,
Yeah.
right? Okay. Now we can write 1 by tr. it will become 8 by this stuff.
Hmm. Yeah.
We have to find limit n tends to infinity. Summation r goes from 1 to n, 8 by 2r minus 1, 2r plus 1, and 2r plus 3.
Yeah.
This is the question now after finding tr or tn.
Yeah.
Okay, so then this step now we have to think about, can we do the summation here in a nice way and figure it out? So first of all, we can see that the difference of these two is 2, and the difference of these two is 4. So
Um.
let's think of what we can do. We can split it first of all. There are we have to do telescoping series, something like that.
Yeah.
So we can say 2r plus 3 minus 2r minus 1, right?
Yeah.
Multiplied by 2, right?
Yeah.
So then it becomes,
Um.
denominator has all three brackets. So when you split it apart, it will become 2 by 2r minus 1, 2r plus 1, minus 2 by 2r plus 1, 2r plus 3, right?
Yeah. It works out.
Then we'll say 2 by 2r plus 1 common, right?
Yeah. You can
2,
just write it as you can just write 2 as 2r plus 1 minus 2r minus 1.
right? In each step, we can write that this also can be split. So we'll get
Yeah.
basically 1 by 2r minus 1 minus 1 by 2r plus 1, right?
Yeah.
Minus 1 by 2r plus 1 minus minus, so plus 1 by 2r plus 3.
Oh, nice. Yeah. Cancels out.
So, okay, so
Oh, wait.
we are getting 1 by 2r minus 1 minus 1 by 2r plus 1. This is one series, minus 1 by 2r plus 1 minus 1 by 2r plus 3. This is another series. And both have to be summed where r goes from 1 to n, right? Correct?
Yeah.
So it is simple, only both. You should do both of them separately, don't combine them.
Yeah. I'll do it separately.
If you do it separately, then first you can see that there will be a lot of cancellations. When you do 1, you will get 1 by 1 minus 1 by 3. Second term would have been 2, so 1 by 3 minus 1 by 5, and so on. Last term would be 1 by 2n minus 1 minus 1 by 2n plus 1. So all of these terms get cancelled. You'll get 1 minus 1 by 2n plus 1 here, right?
Yeah.
Minus here, your starting term is 1 by 3 minus 1 by 5. And then after that, it keeps going on like that. Last term is 1 by 2n plus 1 minus 1 by 2n plus 3.
Yeah. Only 1 by 3 will remain.
This will remain and this will remain, right?
Yeah.
So you're getting minus 1 by 3 plus 1 by 2n plus 3, correct?
Yeah.
So you're getting
And
2 by 3. The summation finally is becoming
2 by 3. Yeah.
2 by 3 minus 2 terms involving n.
Yeah. But n will be infinity. So,
This is what your summation is.
yeah.
When you take n tends to infinity, the answer is 2 by 3.
Yeah.
The point is to not think that it is an obvious thing. You have to think a little bit and
Yeah.
don't make assumptions. If you find Tn correctly, after that it is doable if you know telescoping series.
Yeah. That's right.
But if you can't find Tn, then nothing can be done.
Yeah.
Okay, what is the next one?
Yeah. I'm just sending it.
Okay. Question is saying if alpha is equal to 1 plus summation r goes from 1 to 6 minus 3 to the power r minus 1 times 12c 2r minus 1, then the distance, okay, then the distance of point P, which is 12 comma root 3 from line alpha x minus root 3y plus 1 is equal to 0 is how much? So first of all, let's write the distance formula here. It will be 12 alpha minus root 3 into root 3 plus 1 divided by root
By 2.
over alpha square plus 3. What do you mean by 2?
Oh, sorry. Root 3. Never mind.
You don't know distance from point to a
Yeah,
line,
yeah.
it will be a problem.
No, I just,
You understand what I'm saying?
yeah, I got the distance formula part.
It is 12 alpha minus 2 by root over alpha square plus 3 modulus.
Yeah.
That is what we need, so therefore we need alpha.
Yeah.
So alpha is this, and we have to understand what is happening here. So
Yeah,
alpha is
it's,
1 plus summation of r goes from 1 to 6 minus 3 to the power r minus 1. Okay, minus 3 to the power r minus 1. So basically we can say minus 1 to the power r minus 1, 3 to the power r minus 1, 12c 2r minus 1.
yeah, it's a very weird pattern. It's not a standard binomial expansion.
You don't have to keep repeating how weird it is or how strange it is.
Yeah,
If you're in your mind, you're thinking it's very weird, very strange, and you're not going to be able to get the answer. Do you see
yeah.
me telling this that it's very weird, it's very bad?
No, I was,
You have to say you have to say to your mind that it must be something easy. In
yeah.
you have to think positively when you see the question, not like it's a very weird one, it's bad, it's horrible. If you keep repeating this to yourself, you're not going to get it.
Yeah.
Do you hear me ever looking at a question and saying it's really bad, it's not good,
No,
right? Because the attitude has to be that we will get the answer.
yeah.
If the answer has to be gotten by actual calculation, I will actually calculate it and get it. This is not some very big summation. 6 terms are there. I will calculate it and get the answer.
Cal. Okay.
Is it some very difficult thing to calculate?
No, it isn't difficult, but
Right.
I was just thinking we had to find some. We have to make our own expansion and try to
Right.
find
But
it.
if I'm not able to figure that out in the time, what will I do? I
I
will
didn't think of
calculate
just
6
doing it.
terms.
Yeah,
I
I know
know
it's
basic
just
mathematics. It's just 6 terms.
okay.
If you're not willing to do what it takes, you'll not get the answer. What it takes is maybe you can't figure it out in the exam, so you'll give up.
No, I didn't give up. I just
Uh,
tried doing it, and when it didn't take time, when I took too much time, I just shifted to another question.
this is just one value of alpha that you have to calculate. It's not some big difficult calculation also. You will just say 1 plus, when you put 1, you will get 0 here. So 1 plus 12 C 1. The next term is when you put 2 here, you get a minus 3
Yeah,
power 1 and you get a 12 C 3.
12C3.
then minus 3 power 2, and you get a 12c. When you put 2 here, when you put 3 here, you are getting 5, right? So it is
Yeah.
clearly odd terms are coming. The next
Yeah,
one
that's
will
right.
be this 12c7. Next term will be minus 3 power 4, 12c9. And next term will be minus 3 power 5. When you put r is equal to 6, it will be 12c11, right?
Yeah.
And then it is looking like it is a sequence of 1 plus x power 12, but all the missing terms are there. The terms that are
Yeah.
missing are the even terms.
Yeah.
And then there is minus 3 power 1, minus 3 power 2,
Yeah.
minus
Instead
3
of
power
like,
3. So, okay, so first of all, I can easily, oh, okay. So I can see that 12c9 is same as 12c3, and this is same as 12c1, and this is same as 12c5. So I'm getting actually 12c1, 12c3, right, 12c5 two times, and
yeah, you
12,
have to
no,
calculate
12c3
C1.
also two times.
Yeah.
12c3 two times, 12c1 is there once, and 12c1 is here also. So actually just 12c5 and 12c3 we have need to calculate.
Yeah.
That's it. So 12c3 and 12c5 are not very difficult for me to calculate. It's not an issue. I will calculate and get the answer. 12c3 is 12 factorial by 9 factorial, 3 factorial. So 12 into 11 into 10 by 6. So it is 220. And 12c5 is 12 into 11 into 10 into 9 into 8 by 5 factorial, which is 5 into 4 into 3 into 2. 5 into 2 is 10, 4 into 3 is 12, so it is 72 into 11, so it is 792.
Yeah.
So I have 1 plus 12. This is minus 3 into 220. This is plus 9 into 792. This is minus 27 into 220 into 1292, 792, right?
Yeah.
This is 12c3 again, so plus 81 into 220, and this is minus 243 into 12, right?
Yeah.
So I will simplify, I will say that 220 is coming two times, and I have 1 plus 12 minus 78 into 220 minus 18 into 792, right? No, plus 78 into 220 minus 18 into 792 and minus 243 into 12, right?
Yeah.
Okay, so 792 and 220 and 78 and 18 is that? Okay. Uh, Fine. So I'm getting 1 minus 243 into 12, so minus 242 into 12, and plus 78 into 220 minus 18 into 792. Obviously, I can take 12 common in all three terms here.
Yeah.
So I will do that, and I will get 1 minus 12 common, 242 minus 13 sixes and 2 into 110. So 13 into 110 is left. So 13 into 110 plus, and I'm doing 6 from here. So 3 is left and 2 from here. So 350, 396. So 3 into 396. right?
Yeah.
So this is becoming 900, actually almost 400. So 1200 minus 12, so 1388 plus 242
Yeah.
minus, this is 13 into 11, so 1430. So this
Yeah.
is 200, so 1588 plus 42, so 12, 1600 and 1630. So it is clearly 200, right?
Yeah.
1 minus 2400 I'm getting.
Oh, I'll just
Minus 2399. Minus 2399 is a weird number.
yeah, it seems odd.
I have made some calculation mistake, I feel. But the point is, don't spend too much time on the series summation. Just calculate it. If you
In this
cannot figure
case,
out a pattern, in this case, it is only six terms. You
yeah,
should find the answer. If you cannot figure out the pattern, like there will be a pattern, but it's not like we have too much time in mains to figure out patterns if
yeah,
you
that's the thing.
don't immediately get it. And it's not immediately obvious. It will be some power of 6, I think, and minus 3 will be involved in the binomial function. But you don't have to do it like that. You can just, I mean, I would just calculate it in the exam. There is only six terms. Right now, I feel like I made a mistake somewhere, but you should check the calculations and see. After that, it is you have to put it here.
Okay, yeah,
If we want to figure out the pattern, we can do it. It's just
yeah, I
um,
mean,
you can think of binomial sequences where you have something like 1 minus 3x to the power 12. What will
hmm,
come here? It will be like first term would
um,
be 12c 0 1 power 12. Then it will be minus 12c1 3 power 1 x power 1, right? Plus
yeah,
12c2 3 square x square minus 12c3 3 cube x cube and so on
um,
till you will get till minus 12c11 3 power 11 x power 11 and then plus 12c12 3 power 12 x power 12. This is all the terms of the sequence. We probably won't need all of them. We need only some of them, right? So basically, there are 13 terms here. And
yeah.
what we had was what? 1
You need
plus,
basic,
when you put a r is equal to 1, you get a 12c1. And then next term was minus, when r is
um,
equal to 2, minus 3 into 12c, r is equal to 2, so 12c3, right?
yeah,
So when we get a 12c3 here, we are getting 3
um,
cube x cube, right?
yeah, and
So ideally, I don't want 3 cube here. So that means I should take square root of 3.
yeah.
If I take square
But,
root of 3,
but then you need 12C1 only without any X bar something.
1 second. I have a 3 cube here. And then when the next term was written, here it was a 3 square, 12c5. So the
Yeah,
power here, 3 power
has to be
1.
2 less
Oh,
than the subscript. Um,
so
I was thinking, do we have to multiply this entire expansion with something like 1 by x or 1 by x square or something like that? Mm.
minus 3 cube 12c7. plus 3 power 4, 12c 9 minus 3 power 5, 12c 11. This is what we have here.
Yeah.
And okay, so this is a 1 minus 12c1, 3 power 1. That is the problem. 3 power 1, 3 power 2, the powers are incorrect. If my powers were coming nicely, then it would be done. So, okay. So then, okay, so let me remove this at all completely, and I will put x is equal to 3 later. So if I put x is equal to 3, I'll get 12c1 3, right? No, I'll get
Yeah.
12c1 into 3, which is not correct. I'll get 12c2 3
Mm,
square, 12c3 3 cube.
cube. Yeah. Need 12c3 x and mm,
12c1 into x.
cube. Slow down.
Okay, that will be some
So maybe instead of 1, maybe the term is 1 by x or in the expansion.
3 power r minus 1, x power 2r minus 1, 2r minus Hmm.
No, my-
1 second. Okay, let's not spend too much time right now on this. In the exam, because it's only 6 terms, I recommend just calculating it.
Okay. Yeah.
If you can't figure out a pattern, you'll have to leave it. But the question is only terms, so you should calculate and get the answer and do it, right? Right
Yeah.
now, it is taking too much time to figure out. We'll move on right now. There must be some nice way to get it. I'm not getting it immediately.
Okay. Yeah.
What is the next problem?
Yeah. I'll just send it.
Okay, find the remainder when 7 power 103 is divided by 23 by 23. This is so easy. Why is this a problem?
I wasn't. I tried many times, but it was not coming into a desirable form.
What do you mean desirable form? It is 7 powers. What are the powers of 7 that you know?
Yeah. So I tried in terms of 49 first, like because we know 23 into 2 is 46,
Mhm.
and yeah.
3 to 30, 123. You have to find the remainder. So we will say, okay, 49 only maybe is best. So if you say this is 7 into 49 to the power 51, right?
Yeah.
So 7 into, I will write this as
46
23
50.
into 2 plus 3, right?
Yeah.
If you look at the binomial expansion of this, 2 plus 3 is a problem.
Yeah. So we have to find the remainder from 3 to power 51.
Every term other than the last term will be divisible by 23, right?
Yeah.
So the only term that will matter here is 3 power 51.
Yeah.
So that term will come when you have 51c 51. So that's the only term, right?
Yeah.
So remainder will come from 7 into 3 power 51, right?
Yeah.
Because all the other terms will be divisible by 23, will give remainder 0.
Yeah.
So now
And
question
then
has become this. And
yeah,
now
so
you can say that,
3
what
cube
can we
is
say?
27. 3 cube is 27 and we have 23. So I tried that as well. So you can write it as 7 into 27 past 17. But even so, it keeps getting complicated.
3 power 4 is 81. 23, 3 is a 69. 3 power 5 is 243. Okay. 23 into, what is the closest number to 343? 230 and then
Yeah, so
123. So 115. So
instead, 27 and 23 would be closer.
so I think it is 345 is divisible by 23, right?
Oh, yeah, it is.
So that
23,
is
1.
just
Yeah,
2 steps away.
yeah, that's right. I didn't see that.
So maybe we should have used that. So for example, 3 power 51, we can say is 3 power 5 is 343.
Yeah,
So this is 3 into 3 power 5 power 10, right?
yeah.
So this becomes 21
So
into,
isn't 3 power 5 243?
oh wait, I am making a mistake. 7 power 3 was 343. Okay, I should have
Yeah,
started from the beginning only. Right, right.
yeah.
So I will not do it like this. I will do it using 343.
3, okay.
343 is just 2 less than something divisible by 23,
Oh, wait,
right?
yeah, that makes more sense. Yeah.
I will say here there is 103. So 102 is divisible by 3. So it is 7 into 7 to the power 3 to the power 34, right?
Yeah,
7 into 343 to the power 34. And this is basically 345 minus 2. So 345 minus 2 to the power 34, right?
yeah.
Every term that has 345 is divisible. So all we have to look at is
2,
minus
2
7.
power 34.
So
Yeah.
2 power 34.
And 7.
7 times 2 power 34, whatever is the remainder on dividing by 23, right?
Yeah.
So 2 cube is 8, 2 power 4 is 16, then 32, then 64. 64, okay, no. Then we have
Um,
128, 128, and then 256, 23.
64 and 69 are close.
That's not close enough. 2 power 34. Okay, so 256 and 23 is 230 and 253, right?
Yeah.
So then it will become 3 units apart.
Oh, wait, yeah.
So 2 power 8 is 256. So here we can say it is 7 into 2 power 2 into 2 power 32. So 2 power 8 power 4, right?
Yeah.
So this is becoming 28, by the way, right?
Yeah.
So this is 23 plus 5. So we can remove 23 and we can say just 5 is left, right?
Yeah.
Do you understand what I'm saying? This
Yeah.
28 becomes 23 plus 5. So 23
Yeah.
into this will be divisible. So all what is left is 5. 5 into this power 4, right? Which is
Yeah.
256 power 4. So out of that, 253 will be good for us. So plus 3
Yeah.
power 4, right?
You'll just get 3 power 4. Yeah.
So 5 into 3 power 4 is what is left now.
So we
Now
can
it is
just
doable. 5 into 81, right?
you can just multiply the remainder with the okay, yeah, because we're just finding the remainder. Yeah.
We'll
81 into 5.
just we'll just calculate remainder that you get here is 12, 12 I think. 12 into 12 is the remainder that you get from here. But okay, we can just calculate it. 405. Find the
Yeah.
remainder when you divide by 23. So 230 and then what is left
I'm
is
getting it as
175.
14.
175. So 115,
Yeah,
138,
it's 14. Yeah.
161. Answer is 14 then.
Yeah.
The point is you can't take numbers which are too far off.
Yeah. I thought even 3 is enough.
And also higher powers, you got 343 and 345, which are so close.
Yeah.
If you take two small powers, you'll not get something nice.
Yeah, that's right.
And this also helps us because directly we are reducing it to a big degree. We got it down to this. Once we
Yeah.
got it here, then 2 power 64, then I saw that okay, 256 and 253 are close enough.
Yeah.
Then again, we split the 7 and took a 4 out here. That 28 becomes plus 5 remainder, right?
Yeah, that's right.
28 can be written as 23 plus 5. And when you expand it, 23 times this will be divisible by 23. So only thing that is left is 5 times this.
Yeah.
And then we got 253 plus 3. And then this is divisible. Only thing that will be left is 5 into 3 power 4.
Yeah.
Right?
Yes.
Okay. What is the next one?
Yeah.
Board has 16 squares as shown. So there are 16 squares. One of these, out of the 16 squares, two squares are chosen at random. Two squares are chosen at random. Find the probability that they have no side in common. Probability that the two chosen squares have no side in common. Okay, fine. So let's think about it. So if you choose a corner square, right,
Yeah.
then you cannot choose these three then, right? Each
Won't it
corner
be
square
only
has three squares common to it with sides, right?
um but sir, if you think about it, shouldn't it only be 2 in this case? Because only how is the diagonal square having a side common? It just has an edge common, right? I mean, a corner common.
1 second, hold on. Okay, so we have to find the probability that two chosen squares have no side in common. What I am trying to say right now is if you choose a corner square, how many other squares are there which have sides in common?
Shouldn't it be only two?
Hmm, right. This one does not have a side in common.
Yeah.
Okay, so probability that the two chosen squares have no side in common. So basically, then in that case, once you have chosen a corner square, you can choose anyone other than these two, right?
Yeah.
That would be correct, no, for us.
Yeah.
So basically, then the number of squares available is how many,
13.
right? And you can exclude these two, right?
Yeah.
So 13 by 15, right, is the probability of success after that.
Oh, you have to.
Do you
Okay. So
understand
I
what
thought
I'm
you have to do it
saying?
in. Okay. Yeah.
1 second, just hold on. What I'm saying
Okay.
is, if you have chosen a corner square for the second square to select, right?
Yeah.
Total number of squares are 15, but which are good for you? 13,
Okay.
right?
Yeah.
So probability of success is 13 by 15, right?
Okay. Got it. Yeah.
And probability of selecting the first square as a corner square was 1/4, right?
Yeah.
Because there are how many corner squares?
4.
4
Oh,
out
you
of
have to do it that
16.
way.
So
Yeah.
what I'm saying is, this is case one. If you selected a corner square, our correct having the correct probability is 1/4 here and 13 by 15 here, right?
Yeah.
Do you understand what I'm saying?
Yeah.
Case two. Now we'll select squares which are like this, the ones on the edge here, right?
Yeah.
The ones on the outer edge, the two of them, right?
Yeah.
Such squares are, notice there are how many such squares? 8 of them.
Yeah. That's right.
So the probability of selecting any one of them in the first place would have been how much? 1 by 2,
Yeah.
right? After you have chosen one of them, let's say we have chosen this one. Which squares
Okay.
are not allowed now? This
One,
one,
two,
this one, this one, right?
3 squares. Yeah. So 12 by
So
15.
so basically after now out of the 15 remaining, 12 by 15, right?
Yeah.
Is the correct probability rate.
Yeah.
So now we have taken the cases corners and the edge squares, right? We have taken all those, right?
Yeah.
Only things left are the middle central square, right?
Yeah.
So now we will say that if I have chosen a middle central square, there are four of them. The first step would have been how many, what is the probability I chose one of this? 1/4.
1 by 4. Yeah.
Once I have chosen this, which squares are not allowed?
Um, 1, 2, 3, 4. Yeah,
Right.
so it's 4
One,
and not
two,
allowed.
three, 4, 5, 6, 7, 8, 9, 10, 11. 11 are allowed, right?
Yeah.
Out of the four are not allowed. So 11 by 15 in the next step, right?
Yeah.
And then I have covered all the cases.
Yeah, that's right.
So we are getting 13 by 60 plus 12 by 30. So that is 24 by 60 plus 11 by 60.
Yeah.
So we are getting 13 plus 11, 34.
58
Uh,
by 60.
feel like
Um,
some mistake has happened. Uh,
1 by 4.
I'm getting basically 29 by 30. Something is going wrong somewhere. It is close to the answer. I think the answer will be 23 by 30.
I'll just check it.
Check the answer.
Yeah.
Oh, I'm right. 48 by 60 is the thing. So 4 by 5 is the answer.
Yeah, I'll just check it.
Our calculation is wrong. No? It is.
Probability question. Yeah, it's 4 by 5.
The calculation was wrong. 13 plus 11 plus 24 is 48, not 58. Right?
So just one doubt about the second case where you got half as the probability of selecting an edge
Mhm.
square. How is it?
How
There are
many
eight of
ends?
them, right? And it's a symmetric case, so that's why you're saying 4 by 8 is half, right? Is that the logic?
No, there are 16 total squares. What's
Yeah.
the probability of selecting 8 of the 16?
Oh, that. Yeah, it's half.
First step, you have to select any random type of square. First, we chose the case where we selected corner squares.
Yeah.
Then we chose the case where we're selecting either these two or these two or these two or these two.
Yeah.
How many are there?
There are 8 of them.
There are total how many squares?
Yeah, 16.
So half.
Yeah.
Once you have selected any one of these two, you have to now count how many not allowed. Next step, what is the probability of making sure that this happens?
Yeah, that's right.
Out of the 15 remaining, which ones can you do? Which ones can't you do? And finally, once you have done corner squares and edge squares, we are left with the middle central four squares. You can select 1 by 4 probability is there because it is 4 by 16,
Yeah.
right?
Yes.
After that, you have 11 by 15.
Yes.
Okay, what is the next one?
Yeah, I'll just send it.
Number of relations on A containing 1 comma 2 and 2 comma 3, which are reflexive and transitive but not symmetric. Reflexive and transitive but not symmetric. Okay, so first of all, the relations are from set A to set A, and set A has three elements. So how many elements are there in the Cartesian product?
There are 9.
So total number of relations could be 2 power 9, right?
Hmm. Yeah.
Could be 2 power 9 or 512 maximum, right?
Hmm. Yeah.
But we have to deal with, first of all, relations which contain these two, right?
Yeah.
So already we will select 1 comma 2 and 2 comma 3 ordered pairs,
Yeah.
right? And after that, there are 7 remaining ordered pairs, right?
Yeah.
Do you understand what I'm saying?
Yeah.
So how many possible relations are there now?
Yeah. So they've given us the condition that it has to be reflexive and
We are not
um
talking about those conditions right now. We are
yeah,
not
you
going
have
to jump
said
5 steps. Right now, what have I said?
like how many relations are possible after,
After,
like how many more ordered pairs can be added
if we know that 1 comma 2 and 2 comma 3 is there, how many relations are possible with just this much condition?
with just these two. 7 pairs are remaining, right?
How many relations are possible?
Relations, yeah, 2 power 7.
2 power 7 relations are possible because the remaining pairs can be chosen or not chosen,
Yeah.
right?
Yeah.
So now we have 128 relations possible. And out of
Yeah.
this, we have to select reflexive and transitive, but not symmetric.
Yeah.
Okay. So first of all, they are reflexive. If they are reflexive, which pairs are guaranteed to occur?
1 comma 1, 2 comma 2, and 3 comma 3.
Right. So these pairs are guaranteed to occur if they are reflexive. So automatically, three more pairs have been put in the thing, right? So
Yeah.
total now five pairs are already done, right?
Yeah.
Now let's think of transitive. If 1 comma 2 and 2 comma 3 is present, by transitive property 1 comma 3 should be there,
Yeah.
right?
Yeah.
There is nothing else that is guaranteed by transitivity, right?
Yes, that's right.
So six pairs are already done.
Correct.
Out of the nine pairs, six pairs are guaranteed now, correct?
Yeah.
We have to make sure that it is not symmetric. Not symmetric means at least at some phase, symmetricity should not happen. So basically, we can't do anything about these, right? They are at automatically themselves symmetric.
Yeah.
But we have to ensure that at least one of 2 comma 1, 3 comma 2, and 3 comma 1 is missing. Do you
Yeah.
understand what I'm saying?
Yeah.
There were total nine pairs. We have already put six of them are guaranteed to be present.
Yeah.
What are the three left? These were the three left.
Correct.
So, what are the, in order to make sure that it is not symmetric, what you need to ensure is that at least one of them is missing.
But sir, even if one of them is present, this condition will not be satisfied, right?
Two of them can also be present. All three cannot be present.
But sir, even if two of them are present, then we are saying that 1 comma 3 and 3 comma 1 exists. So it is a reflexive. I mean, it is a symmetric relation then, right? Because
No, you don't know the meaning of symmetric, that means.
oh, it's for all the pairs. Got it.
You don't know symmetric only, how do you solve the question?
I got confused. I thought even if one of them is symmetric, it should not be considered.
One of them is symmetric, then automatically this is symmetric because 1 comma 1 is there. Then how will we have 1 comma 1, 2 comma 2, 3 comma
Okay,
3?
yeah, that makes sense. Yeah. So
Symmetric will be then the meaning of symmetric, the definition is that if A comma B is there, guarantees B comma A is there.
yeah,
That doesn't mean that if symmetricity is true for this, the whole thing is symmetric. It has to be true for everything.
got it. Yeah.
So that means what? Even if one of them is missing, we are done. It is not symmetric.
Okay, got it.
So actually, there are we have eight choices of selecting or not selecting, right?
Yeah.
These three pairs, correct?
Hmm. Yeah.
Out of those eight choices, there is one choice where none of them is there. That is obviously good,
Yeah.
right?
Yeah.
There will be, okay, so none of them is selected and one of them is selected.
It'll be three only, right? Because we are missing each of them once.
Each of them can be missed. Okay, so
Once.
we have to exclude only one case. The answer is seven. We have to exclude one case when all three are there.
Okay.
Do you understand what I'm saying?
Yeah, I got it.
Only all three are there is not allowed.
Yeah.
So out of the 8 choices, what? One choice is not allowed. 7 choices are allowed because in all 7 of them, something will be missing.
Yeah.
Do you understand what I'm saying?
Yeah.
So anyway, you are guaranteeing so many ordered pairs are guaranteed because of the conditions of the problem.
Yeah.
And out of the 3 that are left, total were only 9 pairs were there. 3 were left. Out of those 3, there are 7 ways to make relations where you are only not including the case when all 3 are present. That's the only case missing, right?
Oh, yeah.
Answer will be 7 number of relations.
Yeah, I'll just check.
Do you understand what has happened?
Yeah, we just excluded one case where all three of them are there, and so we basically had nine initially, and
The relations will be like this.
yeah.
1 3 is present by transitive property, 1 1 2 2 3 3 is present by reflexive property, and now we need to make space for remaining 3. One option is nothing, right?
Hmm.
One
Yeah.
option is you can put 2 comma 1 maybe. One option could be you can put 3 comma 2. One option could be you can put 3 comma 1. Then you can put two of them, right?
Yeah. Um,
Do you understand what I'm saying?
yeah, I got that.
The only thing you can't do is put all 3. So if you count, this
Won't
is
it be
1, 2,
six
3,
then?
4, 5, 6, 7. 7 different relations will be there.
Yeah.
Do you understand what is happening?
Yes, sir, I understood the logic.
If you don't know the meaning of each of the terms properly, then you will not get it. If you think reflexive or symmetric means only one of them is true, it is symmetric, then obviously that's wrong. Symmetric means for every term, every ordered pair, the opposite is there.
Yeah.
And if
But sir, the answer is three actually.
the answer is wrong, if the answer is 3, obviously.
Because yeah, it can't be three because when we take the cases, it makes sense that it has to be seven. 2 comma 1 3. Yeah, it does make sense.
This relation is reflexive, transitive, but not symmetric. This relation, if you put a 2 comma 1 in it, it is still not symmetric because 2 comma 3's opposite is not there.
Yeah.
If you put 1 1 1 of them, these 3, you will
Yeah.
get 3 automatically. If you put none of them, you'll get fourth one. If you put 2 of them, you'll get 3 more.
Yeah.
If the answer is 3, the answer is wrong.
Yeah.
Go back to your definitions, find the definitions, and then try the problems.
Yeah.
In the next class, we'll be doing a deep dive into complex numbers and one physics chapter, whichever
Okay.
chapter you prefer out of the list of chapters. So it will be a 2 hour
So
class and we'll do
yeah.
questions on these.
So there was just one question that got missed out amongst my doubts.
I have another class starting, so I can't do it right now. We'll do
Okay,
it in the
sure.
next
Maybe next
class.
class. Yeah.
Okay.
Yeah.
So next class we'll cover one physics chapter and complex numbers and we'll be doing PYQs. So revise it and come.
Yeah, I'll do that. And so what about my physics doubts? Like,
We can do it in the physics time next class.
yeah.
Okay, fine. That's all for now then.
Yeah. Thank you, sir.